All right, so we're going to have a little look at isomerism today. This is 11.4. I want to give you some context before we start. So I'm going to show you a family tree of all the different isomers that you get at A-level chemistry. The one that we are looking at today is called structural isomerism. Of that, there are three types: chain isomerism, positional isomerism, and functional group isomerism. Those pictures should give you an idea of what each one involves. In a few lessons' time, we're going to start looking at stereo isomerism, which has two types. So geometrical isomerism is where you can have a double bonded carbons with different groups attached. That will give you cis trans or EZ isomers. We'll go into that in a few lessons' time. And then next year, you've got optical isomerism coming up, which is really cool, and that is to do with chiral carbons. So what we're going to do is I'm going to stop sharing my screen so that you can see what I'm doing with this molymod thing here. I'm going to make pentane, and then I'm going to rearrange it to make some different compounds. And then I'm going to make pentanol and rearrange that. And we can look at how, there we go. We can look at how changing the structure of this keeps the molecular formula the same, but the structural formula will be different. So here's pentane. Hopefully you can see this. This is a straight chain isomer here. You've got all 5 carbons in a row. They all join together, and you've got 12 hydrogens. So this is C5H12. Now, if we take a carbon off the end and plug it into the middle of the chain, like that, we've now got 4 in a row, and we've got a methyl group up here. What would you name that? So we've got methyl butane, or 2-methyl butane, although there's nowhere else this branch could be. And this is a chain isomer. So the molecular formula is still C5H12, but the structural formula is different. See if you can write the structural formula down. Pause, obviously. Okay, so you might have written CH3, CH, oh God, girl's making a racket, CH3 in brackets, and then CH2, CH3. We can make another structural isomer, specifically a chain isomer of this molecule, by taking another carbon off the end of the long chain, putting it into the middle carbon, like this. Look at that. It's mad. So this is a chain isomer of C5H12. So again, same molecular formula, but we've got a different arrangement of atoms now. So we've got a different structural formula. Longest carbon chain is 3 carbons long, and then we've got 2 methyl branches like that. There, longest carbon chain, 2 methyl branches. What would you name that? Pause and replay when you're ready. So there we go. Longest carbon chain is prop. You could count that from any direction, won't make a difference. We've got a 3 carbon chain. So that's propane, and then you've got 2 methyl groups. So you could call it 2,2-dimethyl propane. Or I guess you could get away with calling it dimethyl propane, because there's nowhere else these 2 branches could go. If they went on the ends of the molecule, we're just extending that carbon chain and it would become bute, pent. So there we go. The next part was looking at making pentanol. So let's do that. Just going to reform my long carbon chain, and I'm going to stick an alcohol group on it, like so. There you go. It's called pentane. It's a 5 carbon chain. It's part of the alcohol homologous series. Structural formula: CH3, CH2, 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 CH2OH. Now have a think about how we can make an isomer of this. This is C5H12O. And we're going to try a positional isomer here. So all I would do take the OH off the first carbon and stick it on the second one. And now we've got pentan2ol. And then I could take this off and I could put it in the middle carbon. There we go. And we've now got pentan3ol. And what about if I took it off and put it on the fourth carbon? What would that be? Hopefully the eagle-eyed among you have noticed. That's still just pentan2ol. So there's 1, 2, 3 different isomers that we could make, different positional isomers of the alcohol, C5H12O. Oh, let me show you that in terms of skeletal formulae then. So I'm going to share my screen. Okay. There we go. So pentane, those are the 3 chain isomers that we've made. Pentane, 2-methylbutane, 2,2-dimethylbutane. And then pentanol, this is what we did. Take that OH, plug it on the second carbon, pentan2ol. Plug it on the third carbon, pentan3ol. Now those are called positional isomers because you've got the same functional group. Nothing's changing about the chain of carbon atoms, but the functional group is just joining onto different carbons in the chain. What's the third and final type of isomerism we're looking at today then? Think back to that family tree. We've had chain, positional, now we're going to look at functional group isomerism. Don't get positional and functional group mixed up. I feel like the naming might be a little bit easy to get the wrong way around. Functional group isomers are where you have the same molecular formula. There we go, that's the common theme here. But you could go from having an alcohol, for example, to, I think what's the easiest way to do this? Now, this is not a functional group you're super aware of, but it works for this example. So I haven't added or taken away any atoms, but now still got C5H12O. Instead of an alcohol, I've got a functional group called an ether, the singly bonded carbon in the middle of the carbon chain. I'll give you a couple of other examples. So there you go, that's a functional group isomer. We've got an alcohol and an ether, same molecular formula, arranged differently. You can have aldehydes and ketones. In this case, you've got a C double bonded O. Try and remember that that's called a carbonyl, this specific combination of atoms. So you've got a C double bonded to an O, a carbonyl. If that carbonyl is at the end of a chain, it's called an aldehyde. If that carbonyl is in the middle of a carbon chain, it's called a ketone. Some people suggest one way to remember that might be that this looks a little bit like a keyhole. I don't know, I think that's pushing it. And then the third type that I've got to show you here is acids versus esters. So we've got a carboxylic acid here, and we've got an ester here. Exactly the same molecular formula. You'll be getting the theme now, but we've arranged the atoms in a different order. All of those types of isomerism have got the same definition, which you must learn. It's so important. Let me go back to the beginning where we have the definitions. Structural isomers are compounds with the same molecular formula, but a different structural formula. Stereoisomers are what we're doing later, and they've got the same structural formula, but a different arrangement of atoms in space. You might want to write those onto post-it notes, stick them, I don't know, onto a bathroom mirror or something, some way you'll see it, and try and memorise those ready for the lesson on 11.4. Thank you for listening. Have a go at your booklet, see how much of that you can get done, and remember, send me any questions that you have about this.